Have you ever looked at a game and wondered what separates a static, digital diorama from a living, breathing world? It's not just about the fancy graphics, it's about the physics. So today, we're going to crack open Unity's physics engine and look at the core pieces that let objects move, collide, and just feel right.
So what's the secret sauce? It's not just making things look pretty. It's all about making them feel right. Giving them weight, making them react when you push them, making them obey the laws of your game's universe. The physics engine handles all of that, but to get it right, you have to start by avoiding a really common trap. Right off the bat, here's the trap. It feels so simple to just teleport an object by directly changing its coordinates. But if you do that, the physics engine gets confused. The result is jittery, totally unnatural movement. It's like a ghost stuttering through the world. To get that smooth, believable motion, we can't just place things. We have to push them. It's a whole different mindset. You have to think like a physicist.
And that brings us to our first key player. For any object to even show up on the physics engine's radar, it needs a special kind of permit. In Unity, that permit is called the Rigidbody.
So what is a rigid body? Well, slapping a rigid body component onto a game object is basically you telling Unity, hey, pay attention to this one. It's part of the physical world now. Suddenly, it can be affected by gravity, it can be pushed around, it can crash into things. Without one, your object is literally just a ghost that the physics engine can't even see.
And this is where the fun starts, because now you get to play with the laws of physics. You can dial in its mass, making a bowling ball feel heavy and a beach ball feel light. You can add drag so it feels like it's moving through air or water. But one of the most interesting settings is Kinematic. Ticking this box is like telling the physics engine, hey, I'm driving this one manually, but everything else still needs to react to it. It's perfect for things like moving platforms or doors.
And this right here, this is the fundamental shift in thinking. We stop teleporting our objects and we start pushing them. We apply forces to create momentum, to build up speed, to make things feel weighty and authentic. But as you'll see, how you push makes all the difference.
Unity gives you 4 different ways to apply a push, called force modes. Using force is like firing up a rocket engine. It's a continuous, steady push. Impulse? That's the crack of a baseball bat, a single, massive, instant kick. Then you have VelocityChange and acceleration, which are kind of like cheat codes that ignore mass. Perfect for when you need super snappy, arcade-style movement.
Okay, this next part is a big one. This is the golden rule of Unity physics. Any code that deals with physics, especially applying forces, has to go inside the fixed update method. Why? Because your game's visual frame rate can jump all over the place, but physics needs a steady, reliable beat to work properly. Fixed update is that constant metronome. You ignore this and things get weird fast.
All right, so we've done everything right. We've got a rigid body, we're applying forces in fixed update, we hit play, our object starts falling with gravity, and whoops, it just went straight through the floor. What gives? Well, our object might have a physical presence now, but it doesn't have a physical shape.
And that's where the next piece of our puzzle comes in: colliders and triggers. These are the components that give our objects their actual shape and substance, defining the boundaries of where they exist in the world.
We keep coming back to this ghost metaphor because it's just so perfect. A rigid body without a collider is exactly that, a ghost. The physics engine knows it's there, and it applies forces like gravity to it. But since it has no defined shape, there's nothing for other objects to actually hit. It just falls right through everything.
The collider component is the solution. This defines the object's physical shape, its hitbox. Now, pro tip, this shape doesn't have to perfectly match your visual model. In fact, most of the time, you want to use simpler shapes like boxes or spheres because they are way more efficient and faster for the physics engine to process.
Now this is where things get really clever. Inside the collider component, there's this one little checkbox, is trigger. And clicking this one box completely changes the game. By default, a collider is a solid wall. But when you check is trigger, it turns that solid wall into a ghostly detection field. Instead of a thud when something hits it, you get a ping in your code that says, hey, something just passed through me.
So let's do a quick thought experiment. You're making a game and your player needs to collect coins. Do you want the player to bonk into the coin like it's a solid gold brick? Of course not. You want them to run right through it, and then poof, you get a point. So what do? You make that coin's collider a trigger. It's the perfect use case: detection without collision.
All right, our world is starting to get busy. We've got our player, enemies, bullets flying everywhere, items on the ground. Everything's got rigid bodies and colliders. If we're not careful, this is going to become total chaos. Not just for gameplay, but our computer is going to start to sweat. How do we bring some order to this madness and keep things running smoothly?
Well, the answer is surprisingly elegant. Layers. You can think of layers as a way to sort all your objects into different teams, and you get to be the referee who decides exactly which teams are allowed to play against each other.
And setting this all up is a piece of cake. You just pop into your project settings, you give a few names to the empty layer slots, player, enemy, collectibles, whatever you need. Then, you just go to your objects in the scene and assign them to the right layer from a little drop-down menu. It literally takes seconds. Once you've set up your layers, you unlock this incredible tool called the Layer Collision Matrix. It sounds complicated, but it's really just a big grid of checkboxes. It's your master control panel for physics, where you decide, with a single click, who can bump into whom.
Check this out. In this example, we've set it so players and enemies can collide with each other, and with the ground. Makes sense. But look at the collectible row and column. They're all unchecked. By doing this, we're telling the physics engine, don't even bother checking for collisions with these things. It's a massive win for performance, and it makes your game logic so much cleaner.
But wait, there's more. The power of layers doesn't stop with collisions. They're also absolutely essential for another powerhouse physics tool, raycasting. A raycast is basically like shooting a tiny, invisible laser beam to see what's in the way. Now, when you shoot that laser, you can give it something called a layer mask. This is basically a filter. It tells the raycast, hey, I only want you to be able to see objects on the enemy layer. So everything else, your teammates, the walls, collectibles, the ray just passes right through them as if they don't even exist. It's targeted, it's clean, and it's incredibly fast. So let's just take a step back and see how all these pieces fit together. Because they aren't just a random collection of tools. They're all instruments in a physics symphony, working together to create a responsive, believable simulation. So what's our recipe for a dynamic world? First, you need a rigid body. That's the core ingredient that brings an object to life. Next, you add a collider to give that living thing a solid shape. If you need a detection zone instead of a solid wall, you just flick on the trigger switch. And finally, you use layers to write the rules of your universe, deciding who gets to interact with whom. That's the whole shebang.
And there you have it. These are the fundamental building blocks of interaction. You literally now have the tools to control an object's weight, its shape, and the very laws that govern its place in the world. The only question left is, what kind of world are you going to create?